Hello, third graders. Welcome to lesson 3.9. Today we're going to be talking about some square arrays and also starting a fact journal that I'm going to get you started on. So let's do this math message first, though. On your slate, it could be a dry erase board or in your notebook. I would like for you to draw an array that has 3 rows of x's and 3 x's in each row. And I want you to write the number sentence that would go with that. All right, what should we have drawn? We should have drawn something that looks like this. Okay, so 3 rows. 1, 2, 3. Each row has 3 x's. So our number sentence, what is our number sentence? What did you write? 3 times 3 equals 9. Remember that we do arrays to represent multiplication and division problems. So not 3 plus 3 plus 3 equals 9. We're kind of beyond that now, right? We know that multiplication is repeated addition, but we want to start thinking about it in terms of multiplication. So what do you notice about the two factors, right? This is a factor, this is a factor. What do you notice? They're the same, right? They're the same. And so when the factors are the same, what shape? It's not a rectangle. We can be more specific than that. What shape did we make there? We made a square. Okay, so we're going to be looking at arrays that are squares today. Okay, we're going to discover some multiplication squares, and then I told you about the fact journal. So really, we're doing two things here, both related to some multiplication. Now, this page, you don't need to open to it right now in your math journal because we're going to have to change it a little bit here online. But we are still going to go through the process here. So our directions here, here's our materials that we don't have. Uh, but here's our directions. We're going to choose a number 1 through 10, and we're going to use centimeter cubes to build an array with that number of rows and the same number of columns, right? We want it to be a square. We're going to record our array, and then we're going to answer these questions. Be ready with these questions here. How are our arrays similar, and how are they different? So I have a group of counters here, and you can see that I have made our first array, right? This array represented 3 times 3 equals 9. So let's do another array. Pick a number between 1 and 10 for me. All right, I heard someone. Someone said 5. And so we are going to now build an array. Ooh, actually, let's make it out of blue. We'll build an array with 5 rows. Try to get them straight here. It's kind of hard here online. And so how many counters do I need to put in each row? I need to put 5 in each row, right? 5 counters in each row because that's what we're supposed to do. That's the directions. That's going to take me a moment. While I'm doing this, I want you to think about what multiplication fact this will show and think about the answer too. Getting closer. Yes, this is fascinating content. Watching Mr. White drag circles. Maybe with our next number, we'll pick a smaller number. Luckily, we didn't pick 10 though, right? We'd have to do it 100 times. All right, here we go. What is the multiplication problem for this array? Good. And if you didn't put the answer, or even if you did, what is the answer here? 5 times 5 equals 25, right? This is, and then look what shape. What shape does this one make? Just like this one, it makes a square. All right. let's do for our last one, let's just do 2 times 2. That'll take less time, right? So 2 times 2. All right. Now I told you about our questions about same and different. So here we have 3 times 3 equals 9, 2 times 2 equals 4, and 5 times 5 equals 25. What's something that is the same about all 3 arrays? Okay, there's several things you could have said. You could have said that the factors are the same, right? 3 and 3, 2 and 2, 5 and 5. You could have also said they create squares. What is something that is different about my 3 arrays? The biggest difference is the number of counters, right? There's other differences too. Maybe you mentioned the color or something like that. But we can have these arrays. They're all square arrays because they make squares. And so these numbers that are the totals here 9, 4, and 25 they're actually called square numbers. But you'll get into that more in fourth grade. All right, so that introduces us a little bit to square arrays. And what we are going to now do is to look in our math journal, starting off at page 135. Okay, so go ahead and open up to page 135 for me. I know it's towards the back, 135. All right, and on page 135, this is our multiplication fact strategy log. Okay, and we're going to be filling out the first 2 of these today. No, actually, we're going to fill out the first 3. So we are going to here to write down our strategy. So one way that we can show multiplication facts is to skip count, right? So I can skip count by 2s to figure out 7 times 2. So 2, 4, 6, 8, 10, 12, 14. So I know that 2 times 4, excuse me, 2 times 7 equals 14. So let's do another couple of problems down here. Let's do another one with 2. 2 times 8. So for 2 times 8, what we need to write underneath here is our skip counting. 2, 4, 6, 8, 10, 12, 14, 16. Right? So 2 times 8 equals 16. Let's put another example down here. Let's do 1 times 5. 5 times, how about 5 times 4? We use it. Skip counting as a strategy for multiplication facts. So we need to do 5, 10, 15, 20. Am I finished? Yes, I am. I am finished because I had to do 5 times 4. So I needed 4 groups of 5. 5, 10, 15, 20. Okay, flip to the next page. Here's another strategy. Strategy for zeros and ones, right? I can think of equal groups to help me solve 0 times 5. 0 groups of 5 means no groups, which is just 0. So examples, anything times 0 is 0. 0 times 8 equals 0. 0 times 30 equals 0. Equals 0. 0 times 2,000 equals 0, right? No groups of 8, no groups of 30, no groups of 2,000 means nothing. Okay? For one group, this says we can attach an array. Yeah, that works too, right? So 1 times 5 equals 5. So let's do 1 times 7. 1 times 7. So 1, 2, 3, 4, 5, 6, 7. 1 times 7 equals 7. Okay, anytime you're multiplying times 1, the other number stays the same. So 1 times 36 equals 36. Okay, so these are strategies that we have used. Now, do I have your page is page 137? Uh-oh, I don't see it. That's okay. You can still do it. I'm looking at it in my math journal right now. If you look at page 137, right, it's on the next page. It has strategies for squares. So you're going to draw some of our arrays that we were doing, right? You could draw, remember these back here? You could draw this and write 3 times 3 equals 9. You could draw this and equal 5, draw, right, 5 times 5 equals 25. On page 137, which you don't see on your screen, here, let's just make it a blank page right now. Page 137. This is the page that you are doing today. And you will be drawing square arrays and writing the multiplication facts that go with them. All right, third graders, that is all. We got a lot done today. We looked at square arrays. We started our fact journal in the back of our math journal. So we did a lot today. I will see you next time. Good luck.